Hello students, welcome to this session. In this video, we have to discuss some of the topics of module 5, in which we have to mainly discuss three particular topics. One is called roots of algebraic and transcendental equation. One is called finite differences, and one more is called numerical integration. First, let us concentrate on the topic, that is roots of algebraic and transcendental equations. In our lower classes, means right from 8th, 9th, 10th and other classes, we are familiar how to solve the quadratic equation, cubic equation, biquadratic equation and so on. Generally, the polynomials are solved by the method of factorization or by the method of synthetic division. But there are some instances where these methods will not able to give the solution for the given algebraic equation. Now, in this particular session, let us discuss how to find the roots of algebraic and transcendental equation using some of the numerical methods. In order to go for considering the methods of finding the roots of the algebraic and transcendental equation, first let us concentrate on some basic things. First of all, we have to understand what is an equation. In order to understand what is an equation, we must know what is function. Suppose x and y are any two variables. If every change in the value of x leads to the change in the value of y, then we say that y is a function of x and we denote it as y equal to f of x. For example, y equal to 2x square plus x and y equal to sin x plus cos 2x. These two are the examples of an function. And when we equate any function to 0, then the resulting is going to be called as equation. That's why we define equation as when any function is equated to 0, we get an equation. That is, if y equal to f of x is any function, then f of x equal to 0 represents an equation. When any function, if we equate that one to 0, the resulting is called as equation. For example, y equal to f of x equal to x square minus 5x plus 6 equal to 0 represents an equation in particular polynomial, and y equal to f of x equal to sin x plus 3 cos x. Again, it is some function of x and it is equated to 0. That's why it also represents an equation. Now, there are types of equations we must know, because our concentration is to know what is transcendental equation. Generally, algebraic equation means polynomials are referred as algebraic equation. In order to know what are transcendental equation, first of all, we have to know the types of equation, starting with algebraic equation, or it is also referred as polynomial. The equation of the type ax cube plus bx square plus cx plus d equals to 0, where x is any variable and a, b, c, d are constants. Such an expression is going to be called as algebraic equation, or it is also known as polynomial, we can call. And next one is trigonometric equation. An equation involving the trigonometric function is called as trigonometric equation. Example, sin 2x plus cos 3x equals to 0. This particular equation involves trigonometric functions, that's why it is referred as trigonometric equation. Now let us come to the third one, that is called as exponential equation. An equation which involves exponents, means e to the power something, is called as exponential equation. For example, e raised to x plus 2 times e raised to minus 2x equals to 0. In this particular equation involves e to the power something, that's why this is referred as exponential equation. Next one, logarithmic equation means an equation which involves logarithmic functions or simply logarithms is called as logarithmic equation. For example, log of 2x to the base e and log x to the base 10 equals to 0. As this particular equation involves the logarithmic functions, of course they may be of different base, but anyhow they are logarithmic functions. That's why such an equation is called as logarithmic equation. And the next one is going to be the transcendental equation. In general, or roughly speaking, we can say that a mixture of all the above type of functions is going to be called as transcendental equation, or we can say it as An equation involving polynomial, trigonometric functions, logarithmics, exponential, etc. is going to be called as transcendental equation. It is not necessary that that equation involve all, but if a few of them are there, then that can be referred as transcendental equation. For example, x cube plus log x plus sin x plus e raised to minus x equals to 0. And this particular equation involve the polynomial, the logarithmic function, the trigonometric function, and an exponential. And such a functions are called as transcendental, such a function is called as transcendental function, and when it is equated to 0, it is referred as transcendental equation. And next, let us understand what is the meaning of root of an equation. The value which satisfies the given equation is called solution or root of that equation. For example, if you consider the equation x square minus 5x plus 6 equals to 0, this equation is satisfied for two values of x. If you take x equals to 2, definitely RHS is 0. If you take x equal to 3 in this equation, again that becomes 0. Therefore, 2 and 3, these are the two values which satisfy this equation. That's why 2 and 3 are called as solution of this equation or root of this particular equation we call. And in general, we can say that the value c is said to be the root of an equation if and only if f of c equals to 0. That is as good as saying the value which satisfies the given equation is called root of that equation. Now let us understand what is the geometrical meaning of root of an equation. Consider one continuous function y equal to f of x, which is continuous in the interval ab. And geometrically, the root of an equation means it is a point on x-axis. That is what we have highlighted here. It's a point on x-axis where graph of the curve meets or intersects x-axis. That is what? It is a point on x-axis where the graph of the function y equal to f of x meets or intersects x-axis. And this particular point is referred as root of an equation. And once it is A, and this point capital A is going to be the point with coordinates A and small a and f of small a, and capital B is a point with the coordinates small b whose x coordinate is small b and whose y coordinate is f of b, which is obtained by taking x equal to b in y equal to f of x. Now from the figure, it's very evident that f of a is the y coordinate in the first quadrant. That's why f of a is positive. And f of b is a y coordinate in the fourth quadrant. That's why it is negative. And once you look at this, definitely their product seems to be negative. That is less than 0. That's why we have written here f of a is greater than 0 and f of b is less than 0. Accordingly, we can claim f of a to f of b is less than 0. With this, we can draw one important conclusion that root of a equation f of x equal to 0 belongs to the interval AB if the product of the ordinates is less than 0. That is, product of the values of the function is less than 0. That is, f of a to f of b is less than 0. That is, root belongs to the interval AB only when f of a to f of b is less than 0. Suppose f of a to f of b is less than 0, then we can assure that there exists at least one root in the interval AB. And this particular diagram will illustrate, suppose this is your A and this is your B, and the curve may be like this. Therefore, whenever the curve meets the x-axis, definitely we are going to get one root. Like that, there may exist many roots between A and B. That's why we have said, or we have used the word at least one. One is assured, means we may get more than one, but one root is going to be assured in the interval AB. These are the two important results we have to remember. That is, root belongs to the interval AB whenever f of a to f of b is less than 0 for the equation f of x equals to 0. Similarly, suppose y equal to f of x equal to 0 is the given equation and f of a to f of b is less than 0, then there exists at least one root in the interval AB. That will be the two important results what we can note here. And there are many methods to find the root of an equation, root of an algebraic and transcendental equation. but for the syllabus they have mentioned only two methods. One is called as Regula Falsi method, or also known as method of false position, and one more is called as Newton-Raphson method, or simply it is known as NR method. First, let us discuss what is this Regula Falsi method. Now, Regula Falsi method or method of false position. In order to discuss this, let us consider one equation, that is y equal to f of x equal to 0 in the interval AB. That is, interval AB is here, and there is one function y equal to f of x, and the way means which is shown here in the figure as y equal to f of x. Now we have to find one root such that f of a to f of b is less than 0. Whenever we find f of a to f of b is less than 0, that indicates root belongs to the interval AB, as it is evident that this particular curve meets the x-axis at this point, which lies in the interval AB. That's why we say that root belongs to the interval AB. Now first let us find this point C, where C is the point where the chord AB, or we can say that first let us join the 2 points A and B. Let it meets the x-axis at the point capital C with the coordinates small c and 0. Now first let us find the value of small c as here. First let us identify the slopes of the chord AB. When we know the coordinates of the 2 points, then the slope of the line joining those 2 points is given by the difference between y coordinates divided by difference between x coordinates. Here, the difference between y coordinate is f of b minus f of a divided by difference between x coordinates, that is b minus a. That will be the slope of the line AB, or the chord AB, I can say it as. In the similar fashion, we know the 2 points B and C, then the slope of the line joining the 2 points B and C is given by, in the similar fashion, difference between the y coordinates, that is f of b minus 0 divided by b minus c. And since 0 is to be neglected, that's why we can write that is f of b divided by b minus c. Now our intention is to solve or find the value of c. Therefore, this can be identified by taking the two left-hand sides are equal and corresponding RHS are equal. That's why we say that when LHS are equal, RHS must also be equal. Accordingly, I can write f of b minus f of a divided by b minus a equals to f of b divided by b minus c. And since we have to find c, by cross multiplying we get c, we get this one, and take that c on the another side and this term on this side, we get this. Once you simplify by taking LCM, we find an expression for c as a into f of b minus b into f of a divided by f of b minus f of a. This will be the value of c. When we get the value of c, again we can drop a perpendicular to the given curve. Then let us join that point to the A point A. Then we let us denote that that particular line meets the x-axis at this one. Let us denote its coordinates as c1 and 0. And now it is very evident that once we get the point C, then the root is either in AC or the root in CB. That's why we can say that then the root, because C is any arbitrary point between AB, definitely the root between either in AC or in CB. Therefore, that's why we have written here, then the root lies in either in the interval AB or in the interval CB. Now, in this case, when the root lies in AC, whenever the product of f of a to f of c is less than 0, then the root belongs to the interval AC. And whenever the product of f of c to f of b is less than 0, then the root belongs to CB. But in this case, we can observe that the marked point, what we have written as root, that lies in the interval A and C. That's why let us take the root lies in the interval ABAC, and let us rename the same interval as A1, B1. Once you proceed in the similar fashion, how we have carried out here, then if you replace A by A1, B by B1, and C by C1, we get C1 equal to A1 into f of B1 minus B1 into f of A1 divided by f of B1 minus f of A1. Then After means if you continue the same thing in this fashion, then we are going to get a point Cn, because here actually our interest is to find the value of this point, that what you have marked as an encircle. First we have started our journey from this, then we come to this point, then we come to this point, means with this way we are approaching closer and closer to the required route. After some steps we are going to get a point, some point which is very close to the required route, or it may almost coincide with the required route. That's why we have said here, means after some steps or after some iteration we get a point Cn which belongs to the interval a and bn, such that f of Cn is approximately equals to 0. This is a symbol which is used to represent approximately equal to. Then the value Cn is called approximate root of the given equation f of x equals to 0. And this method of finding the root of an equation is called as Regula Falsi method, or it is also known as method of false position. Sometimes it is also referred as method of course. And here it should be noted that first we have started from the root is approximated by C. Then next time it will be C1, which is close to the required root as compared to C. Next time we are at C2 and it is close to the required root as compared to C1 and C. Like this, if you repeat this process again and again, we are going to come closer and closer to the required root. And after some steps, we are going to get one point on x-axis which is very close to the required root, or which is almost coincide with required root. And this method of finding the root of an equation is called as Regula Falsi method. And in this method, we have to remember the value of C. How to find the value of C means the formula for C. The formula for C is given as A into f of b minus b into f of a divided by f of b minus f of a. This is the only formula you have to remember while solving the examples on a Regula Falsi method. Now let us discuss some examples on Regula Falsi. Now let us start with some simple example. Find the root of an equation x cube minus 2x minus 5 equals to 0. And here our first step is we have to identify the function. As we know, when any function is equated to 0, we get an equation, means the left hand side of 0 is referred as the function. That's why here f of x equal to x cube minus 2x minus 5. And here we have to identify one interval where the root lies. That can be identified just by going giving different values of for x, so that one value of x should gives the positive value of the function and one value of x should gives the negative value of the function. Starting with the 0, now let us try this process. Once you take x equals to 0, we get minus 5, it is negative. Well, after 0, the next value 1 let us take. Once you take x equals to 1, it will give minus 6. Again, it is negative. The next value, once you take x equals to 2, once you take 2, it will give minus 1. Still, it is negative. Now, for all these three values, it is giving negative. Once you take x equals to 3 here, that is 3 cube is 27. 27 minus 6, that will be 21. 21 minus 5, that is 16. That is positive. See here, for all the three values of x equals to 0, 1, 2, the function giving the negative value, and for x equals to 3, the function giving the positive value. From this, we can observe the following. When we take the product of f of 0 and f of 3, that is negative, because one is positive and one is negative, definitely that product leads to be negative. That's why we can say that root belongs to the interval 0 to 3. Now, once you take f of 1 and f of 3, again f of 1 is negative, f of 3 is positive. So again the product is negative. Accordingly, we claim that the root belongs to the interval 1, 3. Again, if you take 1 and 2, f of 2 and f of 3, again the product becomes negative. Therefore, we can say that root belongs to the interval 2 to 3. This we are claiming by this particular result, that root belongs to the interval AB whenever f of a into f of b is less than 0. That means whenever f of a into f of b is less than 0, then we can say that root belongs to the interval AB. That's why we have written all the three. Then the problem is which interval has to be considered. That's why let us go with one justification what interval has to be considered. Let us find the length of the interval for each of these. First, length is given by upper limit minus lower limit, that is 3 minus 0, that is 3. Here it is 3 minus 1, that is 2, and here it is 3 minus 2, that is 1. And here, while finding the root of an equation, we have to use or we have to prefer the interval of least length. That's why here we have written that one in the form of a note as, while finding the root of an equation, the interval of least length is preferred. And once you observe, among these, one is the least length and the corresponding interval is 2, 3. That's why you have to choose the interval 2, 3 for the computation of the root. Now let us apply the Regula Falsi method, and in this case I try to convince what is the actual procedure of calculation of the root using one table format. First iteration number, first the row titles, the means first row which has so many titles. The first column is iteration number, the second column is A, the third column is B, and the fourth column is C, where C is given by, that is A into f of B minus B into f of A divided by f of B minus f of A, that we have written. Then we have to calculate the functional value at x equals to A. Then we have to calculate the functional value at x equals to C. Then we have to calculate the functional value at x equals to B. F of A means the value of the function f of x at x equals to A. F of C means the value of the function at x equals to C. And f of B means the value of the function at x equals to B. And we know that f of x we have written here. And first, let us start with AB. And the first root means interval we have chosen as, it is here clarified that the interval of least length will be preferred, and the least length is 1. The corresponding interval is 2, 3. If we take the 2, 3 as our first interval, and first, now in order to calculate C, the value C, and it is evident that the value calculation of C requires 4 values, namely A, B, f of A, and f of B. That's why now we know A and B. Now let us find f of A. The meaning of A is the value of the function at x equals to A. Once you take x equals to 2 here, already we have computed, that is minus 1. That's why f of A is minus 1. Now f of B means it is the value of the function at x equals to B. In this case, B is 3. Once you take x equals to 3, its value is 16. That is f of B equals to 16 we have written. Now once we know 4 values, namely A, B, f of A and f of B, we can calculate C using this formula. That is, C is given by A into f of B minus B into f of A divided by f of B minus f of A. And you people actually calculate and realize whether what the values here we have written, they are correct or not. Therefore, once you take these values, namely A into f of B minus B into f of A divided by f of B minus f of A. Once you take these 4 values and if you substitute here, definitely we get the value of C as 2.0588. 2.0588 we'll get. In order to complete one iteration, we have to calculate f of C. F of C means it is the value of the function at x equals to C. In the first iteration, the value of C is 2.0588. Once you take x equals to 2.0588, we get the f of C value in this fashion. Okay, that completes one iteration. Now again, when you are going to the next iteration, we should be very careful what is our next interval, means what are our next values of A and B. And here, after completion of one complete iteration, let us see the product of f of A into f of C. Now here, this is positive, this is positive. Therefore, the root will not lies here. And now let us take the product of f of C into f of B. Therefore, one is negative, one is positive. Therefore, the product is negative. That's why we can say that root belongs to the interval CB. That's why this marking is written in to highlight that if the product of these two is less than 0, then the root belongs to the interval AC. If the product of these two is less than 0, then the root belongs to the interval CB. In this case, the product of these two is less than 0. That's why we have highlighted the underlined or we are highlighted saying that the product of these two is less than 0. That's why the root belongs to the interval CB. From the previous steps, choose the values of C and B, and they are our new values of AB. Therefore, C is 2.0588 and B is what? 3 itself. Therefore, these are our new values of AB. And see here, in this particular process, every time we have to calculate two values. One is C, another one is F of C. And rest of the four values will shuffle there itself. I'll explain here. And it is evident that the product of F of C and F of B is less than 0. That's why the root belongs to the interval CB. From the previous step, once you take the values of CB, they are our new values of AB. This is the C and B is 3 itself. Now, again, in order to calculate C, we need four values, that is A, B, F of A and F of B. Therefore, now A is there. Now, I'll write F of A now. And F of A is the value of the function at x equals to A. In this case, A is 2.0588. But in the previous step, this A is our C, and we know the corresponding functional value, that is minus 0.3911. Now that can be shifted here. Okay, once again try to understand what we have written here. This new A, in the previous step it is C, and we know F of C, means we know the corresponding value of the function at x equals to C, and that is minus 0.3911. That we can bring here. Since there is no change in the value of the B, that's why there is no change in the value of F of B also. Therefore, F of B remains 16 itself. Now we know A, B, F of A and F of B. Then using these four values, one is A, another is B, another is F of A, another is F of B. Then we get one more C value as 2.0813. And this 2.0813 is obtained using the values of A, B, F of A and F of B in this particular formula. And once again, if you take this value, in order to complete this iteration, we have to calculate F of C value. F of C means it is the value of the function at x equals to C. In the second iteration, the C value is 2.0811. If we take this value here, definitely we are going to get it as minus 0.1468. Now again, it completes second iteration. Now again, we can see where the product of the ordinates is negative. Once you take these two, this is negative, this is negative. Here the product seems to be positive. And once this is negative and this is positive, therefore the product seems to be negative. That's why again the root lies in the interval CB. Therefore, from the previous step, let us choose the values of CB as new values of AB. C is 2.0813, B is 3 itself. That we have taken here. Now again, to calculate C, we need two more values, that is F of A and F of B. Now A is this one, that I have tried F of A and F of B I have tried. This new A, in the previous step it is C, and we know the corresponding value of F of C. That's why let us bring that one here. No need to calculate once again, just we have to shuffle there itself. Since there is no change in the value of B, therefore there is no change in the value of F of B. That's why now again we have four values, that is A, B, F of A and F of B. Once you take these four values in the function, in the value C equals to this one, we get that one as 2.0897. And once you take this value in the function, that leads to, that is minus 0.054, and this is almost 0. That's why the corresponding value of C is called as approximate root. That's why here in the problem they asked us to carry out 3 iterations. That's why here we have written, after completion of the 3 iterations, the approximate root of the given equation is, that is 2.0896 or 97, we can say it as. That will be the required value or required answer. We can say actually it should be 7 rather than 6. Okay, now this is the way how we can go for calculation of C and F of C. That will be the very, as I told you, in this particular method, no need to go for fresh calculation of all the functions. Every time you're supposed to go with one particular value C and the corresponding functional value. that we have to concentrate. Okay, now let us go with one more particular example, which is very important. Many times it is asked in the examination. Find the root of the equation x into log x minus 1.2 equal to 0 using regular Falsi method. Carry out 3 iterations. Again, the LHS of the equation is referred as function. That's why here it is x into log x to the base 10 minus 1.2. Now I want to make one thing very clear, that in the calculator there is one key, that is log, direct key, and that log key will be used when the base is 10, and whenever the base is e, we have to choose one more key, ln, in the calculator. That's why this thing you have to keep in mind. Whenever the base is 10, you have to use the usual log key in the calculator. Whenever the base is e, you have to use ln, that is natural logarithm key. Now again f of x is this one. Now again we have to go and give the values for x as a different values, so that one value of x should give the functional value as positive, and one value of x should leads the functional value as positive. When you take x equals to 0, it will give minus 1.2. Once you take x equals to 1, it becomes minus 1.2. Once you take x equals to 2, it will give minus 0.5979. Once you take x equal to 3, it will be 0.2314. See, for first three values of x, namely 0, 1, 2, the function gives the negative values, and for the value x equals to 4, the functional value becomes positive. That's why we can conclude that the product of f of 2 into f of 3 is less than 0. That's why the root belongs to the interval, that is 2 and 3. Now again, by applying the regular Falsi method, let us see how the root can be computed. The first column is iteration number, the next column is A, the next column is B, the next column is C, which is given by, that is A into f of B minus B into f of A divided by f of B minus f of A. Next f of A, next f of C, and next f of B. Now here I want to tell why that f of C is taken in the middle rather than after taking f of B. See here it's very easy to realize whether the product of these two is negative or the product of these two is negative. If the product of these two is negative, then the root belongs to the dual AC. If the product of these two is less than 0, then the root lies in CB. That is only intention we have taken C in the middle of f of A and f of B. Now our first interval is 2, 3, means our A and B value are 2 and 3. Now we have to write f of A and f of B, because the calculation of C requires 4 values, namely A, that is this one, B, that is this one, then f of A, that is this one, then f of B, that is this one. That's why anyhow we have written AB. Now let us calculate f of A. F of A means it's the value of the function, that is this one, at x equals to A, that is A is 2. Already we have computed f of 2, that is minus 0.5979, that we have written here. F of 3 means it is a value of the function at x equals to 3. That's also computed as f of 3 equal to 0.2314. Now let us write that one here. Now once we take the values of A, B, f of A and f of B, in this one we get the value of C as 2.7209. And in order to complete that iteration, if you take, we want f of C. F of C means it's the value of the function at x equals to C. C is 2.7209. If we take this value in the function, we get the value as minus 0.0172. Now again we can observe this into this, both are negative, their product is positive, that side root will not lies, and the product of these two is negative, one is negative, one is positive. Definitely the product is negative, therefore root lies in the interval C and B. We can conclude from the previous step. Let us choose C and B as our new values of A and B. Therefore C is 2.7209, B is 3 itself. Now again A and B are available. We have to calculate f of A and f of B now. As I told you, no need to go for the fresh calculation, because every time we are supposed to calculate two values, one is C, another is f of C. The rest of the values will be shuffled from the previous step itself. Now this new A, in the previous step it is C, and we know the functional value f of C, just to bring that one here, that we have written this one here. and there is no change in the value of b, therefore there is no change in the value of f of b. Now again the product of these two is negative, the product of these two is positive, that's why the root belongs to the interval that is a and b. Sorry, the product lies in the interval c and b. Therefore from the previous step, let us choose the values of c and b as our new values of a and b. C is 2.7401, B is 3 itself. Again f of a, now I want to write this new a. In the previous step it is c, and we know the value of f of c, just we can transfer that one here, and since there is no change in the value of b, therefore there is no change in the value of f of b. Again, once you use a, b, f of a and f of b in this formula, we get the value of c as 2.7406, and once you take that value in the function to get f of c, we get it as almost 0, that is 0.0000. That's why when we take x equal to this, the functional value is almost 0, means that will serve as the approximate truth. That's why we can write after 3 iterations, the approximate solution or the root of the given equation is 2.7406. That will be this way. Now here in these two problems, they asked us to carry out 3 iterations here. In this case also they asked us to go with the 3 iterations. Sometimes they mention the number of iterations to be carried out, and sometimes they ask the accuracy. In this case, let us see how they are asking the accuracy. Find the approximate root of the equation corrected to 3 decimal places. I'll explain what is that 3 decimal places of accuracy. Corrected to 3 decimal places using the method of false position, and the equation is x equals to e raised to minus x. Now once you bring all the terms on one side, we can write it as x minus e raised to minus x equal to 0. Therefore left hand side will be taken as a function, that is x into e raised to minus x, that is the function. Now we have to find one interval where the root lies by taking some different values for x, so that one value of the function should give positive value and one value of the function should give negative value. Once you take x equals to 0, we get minus 1 here. Once you take x equals to 1, we get this one. That's why this is negative and this is positive. The product leads to a negative. That's why we can conclude root belongs to the interval 0 to 1. Now we can start with the interval 0 to 1. But if you start with the interval 0 to 1, and in order to get the 3 decimal places of accuracy, we require to carry out more number of iterations. In order to reduce the number of iteration, now we have to identify one interval of length 0.1 in the interval 0 to 1 where the root lies. Means in the interval 0 to 1, we have to go on take some values in this interval for as x, so that one value of x should be positive, functional value should be positive, and one value of the function should be negative. Now choose the values from this interval in the for x and go on calculate the functional value. Therefore now let us start with the moderate value, that is midpoint, that is 0.5. Once you take x equal to 0.5, we get negative value. Once you take x equal to 0.6, we get positive value. That's why here we can start with f of 0 also. Unfortunately, if you go on calculate, it will be at the end we get positive value, then we have to travel too much. That's why if you start with a moderate value, it is better. That's why here I started with a moderate value, that is 0.5. That is f of 0.5 is minus, and f of 0.6 is this one. F of 0.5 means in the function you have to take 0.5, and f of 0 means in the function you have to take x equal to 0.6. One is negative, one is positive. That's why we can write f of 0.5 to f of 0.6 is negative. That's why the root belongs to the interval 0.5 and 0.6. That's why length is 0.1. This thing has to be keep in mind, because whenever the accuracy is asked, once we go with the interval of a higher length, definitely we have to execute more number of iterations. In order to reduce the number of iteration, okay, we have to identify one interval of length 0.1 where the root lies for the given function. In this case, we identified one root as 0.5 and 0.6 of length 0.1 where the root lies. Now let us apply the Regula Falsi method. Therefore, for the first iteration, as usual, the columns remain same. iteration number A, B, C, f of A, f of C, f of B. Now for the first iteration, A and B values are 0 0.5 and 0 0.6. Now the calculation of C requires four values, namely A, B, f of A, and f of B. Now A, B are there. Now we have to calculate f of A. F of A means the value of the function at x equals to A, that is 0 0.5. When x is 0.5, we already calculated, that is minus 0.1065. When f of means when x is 0.6, that is B, we calculated f of B, that is 0.6 as 0.0511. Now using A, okay, A, B, okay, then f of A and f of B. In this C, we get C equal to 0.5676. And see, one more thing you have to keep in mind. Always the point C lies between A and B. By some calculation mistake, if your value of C exceeds this limit, there is an indication that calculation mistake is there. That's why we have to recalculate, and in order to ensure that the C must be, the value lies between A and B. Now to complete one iteration, C is computed. Taking this value of C here in the function, we get f of C like this. Now again we can observe this into this is negative, whereas this into this is positive. Therefore in this case the root lies between A and C. From the previous step, you have to choose the values of A and C as our new values of A and B. A is 0.5, we have written here, and C is, it is there, that is 0.5676. Again, this value of A, there is no change in the value of A, therefore there is no change in the value of f of A, and the B value is 0.5676, but we want f of B. This B, in the previous step, it is our C, and we know f of C value, just you bring that one here. Okay, that's why now we got A, B, f of A and f of B. Using these four values, we got 0.5672 as the value of C. And once you take this value in the function, it is going to be this one. It is called as f of C. It is almost 0. That's why we can say that this is the required root. Now let me explain what is the third three-digit accuracy. Now we have to go on calculate the value of C, and after calculating the value of C, after successive calculations you have to compare the digits after the dot. In this case we can observe after the dot two successive values of C, after the dot three digits are coincide, and this is the way how we can conclude that this we have achieved three-digit accuracy. If after the dot one digit coincides, that is called one digit accuracy. After the dot, if two digits are coincide, then that is called two-digit accuracy. After the dot, if three digits are coincide, like here, then it is called as three-digit accuracy. And after the dot, if four digits are coincide, then that is referred as four-digit accuracy. Now, in this case, what is asked, we achieved, that is three-digit accuracy. That is after the dot 5, 6, 7, they are same. That's why we say that the required root corrected to three decimal places is 0.5672. That will be the required answer, we can say it as. Now let us go to the next one more. Okay, like this. That is, find the root of the equation x into e raised to x equals to cos x using regular Falsi method corrected to three decimal places. And here, once you take all the terms on one side, the LHS is referred as 0. The LHS is referred as f of x, as x into e raised to x minus cos x. Now again, we have to, and one more thing we have to keep in mind, whenever the trigonometric equation is there, trigonometric function is there in the given function, okay, then we have to put the calculator in the radian mode. That is, that can be done once you go on press mode button in the calculator. At some stage, we observe radian, degree, radian, gradient. That's why you have to put the calculator in radian mode. That is one important thing you have to keep in mind. If you forget this, we are going to get wrong values of the roots. That's why we have mentioned that one as a note. It means whenever the given function contains the trigonometric functions, okay, the calculator has to be put in the radian mode. That we have to follow. Now first let us identify one interval where the root lies. Once you take x equals to 0, we get -1. after putting the calculator in radian mode. Once you take x equals to 1, we get that is 2.178. One value of the function is negative and one value of the function is positive. Therefore, the product leads to negative. That's why we say that the root lies in the interval 0 to 1. But since the accuracy is asked, now from this interval we have to choose some values for x so that one value of the function should be positive, one value of the function should be negative. That's why, as I told you, to go with the moderate value, that is middle point. Okay, that is f of 0.5 is this one, that is minus 0.0532, and f of 0.6 is 0.2679. One is negative and one is positive, therefore the product is negative. And we say that since f of 0.5 into f of 0.6 is less than 0, this implies root belongs to the interval 0.5 and 0.6. That's why now we have identified an interval of length 0.1 where the root lies. Now again writing the same thing, the iteration number a, b, c, f of a, f of c, f of b. For the first iteration, okay, our values of a and b are 0.5 and 0.6. No doubt we can go with the 0 and 1 also. But once we go with the 0 and 1, the number of iterations required to get the required root, okay, that goes increasing. That's why we are identifying an interval of length 0.1 where the root lies. Now, for the first interval, the value of a is 0.5, the value of b is 0.6, and the value of f of a. Okay, f of a means the value of the function at x equal to a, that is 0.5, and we know f of 0.5 is minus 0.0532. Okay, and f of b is 0.6, that is 0.2679, that we have written here. Now once you take a, b, f of a and f of b in c, we get the value of c as 0.5166. We can observe this 0.516 lies between 0.5 and 0.6. Always. Okay, the value of c must lies between a and b. By some calculation mistake, if the value of c lies outside this interval, that indicates that there is some calculation mistake is there, and it will give you a chance to overcome your mistake. Once you take this value of c in the function, we can write f of c like this. Okay, that is minus 0.0035. Now, as we observe, this into this is positive, this into this is negative, therefore the root lies in c and b. From this step, let us choose c and b as our new values of a and b. C is 0.5166, b is 0.6. And now again f of a, this new a, in the previous step it is your c, and that c we know the value of f of c like this. Just to bring that one here, that is minus 0.0035. Since there is no change in the value of b, therefore there is no change in the value of f of b. Again, once you use the values a, b, f of a and f of b, we can get the value of c like this. Once you take this value of c in the function, we are going to get the value of f of c like this. Again, this into this, and here we need a 3-digit accuracy. Now we got two successive values of c. Now we can observe after the dot, only 2 digits are matching, that is 5, 1. But we need 3-digit accuracy. That's why let us go to the next iteration. This into this is positive, this into this is negative. Therefore, the root lies in c and b. Therefore, from the previous step, we have to choose to the next step c and b as our AB. C is 0.5177. This is 0.6. If we take this value, okay, now I need f of a and f of b. Since this a in the previous step it is c, and we know f of c value, we can drop that one here, bring that one here. And since there is no change in the value of b, therefore there is no change in the value of f of b. Again, using a, b, f of a and f of b, okay, the value of c we get it as 0.5177, and once you take this value in the function, we get it as minus 0.0001. Now we can observe here, in these two successive values of c, after the dot, 3 or almost 4 values will coincide. That's why that means you have to stop the iteration here, and we can write the thing that the required root corrected to 4 decimal places is 0.5177. That is the way how we can calculate the value or the root of the given equation. Now there is some different kind of values. And in the four problems, what we observed or what we have solved so far, in all the problems, one thing is common. Every time they are given one equation to find the root of that one. But in this problem, the equation is not at all given. And simply the statement is given like this. Let us see how we can manage in this case. Find the fourth root of 12 using regular false method corrected to 3 decimal places. Means there is no equation at all. Means we have to construct the equation using the given information. And here we have to find fourth root of 12 that can be written as like this. That is under root, that is the fourth root of 12 is written like this. Since we don't know the value of this, let us denote the value of this one as x. Now raising both sides by the power 4. Okay, or this one can be written as 12 raised to 1 by 4 equal to x. Once you raise both sides by the power 4, we get it as x raised to 4 equal to 12. Taking that one on the another side, that is x raised to 4 minus 12 equals to 0. This is the way how we have to construct the equation whenever the equation is not given, some information is given. That simply are taken fourth root of 12 as among x. This can be written like this. Taking or rising both sides by power 4, we get this. Taking this 12 on the other side, we can get this one. Let us refer this one as equation. Now, the left hand side of the equation is taken as a function. Now, let us give some values for the x so that one value of the function should be positive and one value of the function should be negative. Once we take x equals to 0, therefore it will be minus 12. Once we take x equals to 1, it becomes minus 11. Once we take x equals to 2, that is 2 raised to 4, 16 minus 12, that is 4. And we can observe product of this and this is negative. That's why we can conclude that root belongs to the interval 1 and 2. Now again the accuracy is asked. Now we have to identify one interval of length 0.1 where the root lies. That's why what we are required to do is that from this interval we have to choose some values for x so that one value of x should lead the functional value as positive and one value of x should lead the functional value as negative. Once we go on take first one, that is the moderate value is 1.5. Therefore 1.5 if we take, it will give this one. If we take 1.6, it will give this. 1.7, it will give this. 1.8, if you go and take the value of x equal to 1.5, 1.6, 1.7, 1.8, we get this. And once you take 1.9, it will give this. Since for 1.5, 1.6, 1.7, 1.8, the function leads the negative value. For x equals to 1.9, the function gets the positive value. That's why we can conclude the product of these two is negative. That's why the root lies in that interval, that is 1.8 and 1.9. And it is easy to observe that length is 0.1b. That is nothing but the difference between upper limit and lower limit. Now again, as usual, iteration number A, B, C, f of A, f of C, f of B. For the first iteration, A and B values are 1.8 and 1.9, and their functional values are also available. For 1.8, the functional value is minus 1.5024. For 1.9, the functional value is 1.0321. Taking the values of A, B, f of A and f of B in the formula C, we get a C value as 1.8593. And once you take this value in the function, we get f of C like this. Now we can conclude that this into this is positive, whereas this into this is negative. Everywhere we have highlighted or we have underlined where the product is negative. In this case, the product of these two is negative. Therefore, the root lies in the interval CB. From the previous step, we have to choose the values of C and B as our new values for A and B. C is 1.8593, B is 1.9. Again, this new A in the previous step, it is our C, and we know the value of f of C. Therefore, just we can bring here. And since there is no change in the value of B, therefore there is no change in the value of f of B. Again, we can conclude or we can calculate using four values A, B, f of B, f of A, and f of B in C. We get f of C value as 1.8612. Once we take this value in the function, we get f of C value like this. So once again, I will tell you, at every iteration, we are supposed to calculate only two values. One is C, another one is f of C. and rest of the values will be shuffled from the previous step itself. Therefore, now again, this into this is positive, this into this is negative. That's why let us take the C and B from the previous as new values of A and B. That is 1.8612 and 1.9. And f of A, that is this A. In the previous step, it is C, and we know f of C value. Just we can bring that one here. No change in B, therefore no change in f of B. Using the four values, namely A, B, f of A, and f of B, the value of C is given as 1.8612. And here, once you take the calculation, once you take this value of x in f of x, we get C like this. F of C, not C, f of C. And we can observe here to here, only one digit coincides. That is after the dot, only 8 is the one digit which will coincide. Once you compare the second and third values of C, therefore almost 4 digits are coincide. That's why we can conclude, or we can stop here and we can conclude that the required root corrected to 4 decimal places is 1.8612. That will be the fourth root of the 12. We can check this one using the calculator also, taking 12 to the power 1 by 4. Let us see what you get there. Definitely, I think it will answer might be near equal to 1.8612. Okay, this is all about the first method of finding the root of an algebraic and transcendental equation, that is going to be called as Regula Falsi method, we can say. And in this method, one important thing we have to remember the value of C, how to calculate C. That is, C is given by A into F of B minus B into F of A. And the pressure is, first you have to identify one interval AB so that f of A to f of B is less than 0. Okay, and using the four values A, B, f of A and f of B, we have to calculate the value C, and we have to write the value f of C. Next step, we have to see where the root lies by computing f of A to f of C. If f of A to f of C is less than 0, then the root lies in AC. If the product of f of C to f of B is less than 0, then the root lies in CB. That's the only thing you have to keep in mind. Okay, this is the first method, that is Regula Falsi method. Okay, in the next video, let us discuss the second method of finding the root of an interval, that is going to be called as method, or we can call it as Newton-Raphson method. Thank you.